or inconsistent? Yeah, consistent, right? Consistent. Is it independent or dependent? Independent, right? Because they two separate lines. They kind of go their own ways. Think of it, independence, like you have your own path to go. The middle one is no solution, because those two lines can stretch out forever, but never meet each other, right? So they don't have a solution. That means we call them inconsistent, right? And then those two lines are independent because they have their own path. The third one is actually two lines on top of one another, but we don't see it because they're on top of one another. In this case, how many solutions do we have? Well, this is one because they touch each other at one point. Here they kind of lay on top. So infinitely many, right? It's like, yeah, it's like you stacking like table on top of table, like face to face, right? Okay, they touch everywhere, right? So as soon as you touch everywhere, then you have infinitely many solutions. So so it's consistent because you have at least one solution. It's dependent because you have the same path, right? One is dependent on another. Now, if I would represent just an FYI, you don't have to know this, but it's a good thing to know. If I were to write this in a term of a system of equation in algebra, one equation is gonna be like a multiple of another equation. So basically it's the same. All you do is just double it or triple it, right? So maybe one line is longer, but they actually do the same thing, like twins. Okay, now we talk about three variables. It's no longer xy, it's xyz now. A linear equation with three variables where a, b, c, and d are real numbers. A, b, c are not all zero, is of the form like this. I have ax plus by plus cz equal d. ABC is just ABCD, just coefficient, just numbers. XYZ is the variable. Now, geometrically speaking, your graph is no longer a line. It's a plane. It's the whole sheet. Like think of paper, right? It's the whole sheet. So it's the same thing with one solution, no solution, or infinitely many solutions. If the three sheet or three equation have one solution, it may look like this. Right? So the light blue, dark blue, and the orange sheet, they kind of touch each other at one point. Let me see, I have another example of one solution. Yeah, maybe I have another example. I don't know if you guys can, I don't think they can see me. Now the people, no, they cannot see me, but for those of you here, think of it, the table is the plane, right? That's one equation. And I have here is another equation. And here's another equation. One solution, it can be look like this, right? Can touch at one point. No solution means those three planes are parallel. It's kind of like two lines, but three planes are parallel. If you had infinitely many solution, it look like this, right? So those three planes kind of meet at one line, and in a line have infinitely many points. Or you can think of a book, your book. Well, we all use iPad here. Think of a book, right? You turn a book, you see all those pages, they kind of stuck in the middle, right? So they kind of meet each other right there as infinitely many solutions. Okay, so I just want you to know, what does that mean? Just like explain it to you later. When you solve a system equation, you have one solution, you have no solution, you have infinitely many solutions. You kind of get a sense of how does it look geometrically. But I'm going to show you how to do this algebraically, right? Algebraically. So let's take a look at this example. Okay, so when solving two by two, I already show you how to multiply a equation by number and then add to another equation to eliminate a variable, right? We do the same thing here. So the first step is I want to focus on one variable and try to eliminate it. Remember, I said I'm going to focus on one variable. So my my goal is, the goal to solve for this is I'm gonna go from 3 by 3. Right now we have 3 by 3, 3 equation, 3 variable, and then go down to 2 by 2, which is what we did before in 4.2, I believe, and then to 1 by 1, or 1 variable, right? So let's do that. So I'm gonna focus on 1 variable and try to eliminate it. I'm gonna choose y. You can choose any variable you want. You can choose x. Somebody else can choose z. But because I see y have opposite side, it's just easier for me. So the first thing first, I'm gonna pick randomly 2 equations and try to eliminate y. So first thing first, I'm gonna pick say 1 and 2. Right. So I'm gonna label this 1, 2. The equation 3. So I need to eliminate y. So what do I have to do to equation 2? What do I have to do to equation 2? Yeah, I'm gonna times equation 2 by 2, right? So that means equation 1 add to -2 equation 2. See what happened? Let me put a little bullet point here. Okay, equation 1 is 2x minus, just rewrite it, 2 minus 2y minus 3z equals 0. Am I sharing my screen? I'm sharing my screen. Okay, now equation 2, you have to double it. So it's gonna, everything doubles. So 2x plus 2y minus 8z equal 10. Make sure you do the same thing to the right hand side. And now you add, maybe I'll use red, it's fine. I need blue later maybe. All right, now I can eliminate y. So that I have 4x, if you add 2 equation 2 plus 2x plus 2x is 4x. Negative 3z minus 8z is minus 11z equal 10. I'm gonna call this equation 4. Now I need one more like this. I need one more equation that has x and z in it, right? So again, I'm saying I'm focused on eliminate y. I'm gonna do the same thing. It just don't pick the same 2 equations. Okay, now I'm gonna pick another 2 equation. It could be 1, 3 or 2, 3. What do you think? What do you think? 1, 3 or 2, 3? Up to you. To eliminate y again, because we need one more like 4. 2, 3, right? So it's already plus 1 minus 1. Yeah, it's easier to do 2, 3. Okay, as long as you don't do 1, 2 again, you're okay. So 2, 3. So what I'm going to do is I'm going to take equation 2, add to equation 3. I'm going to rewrite it for the sake of the note. Okay, so equation 2 is x plus y minus 4z equal 5, and then 5x minus y minus 7z equal -1. Let me move it up a little bit. And then you add, what do you have? 6x, y is gone, minus 11z equal 4. All right, I'm gonna call this equation 5. So from equation 4 and equation 5, you see something familiar? Right? You know how to solve with 2 by 2? Okay, all right. So third step, put 4 and 5 together. 4 is 4x minus 11z equal 10. And then 5 is 6x minus 11z equal 4. You guys know how to solve for this, right? We did this before in 4.2. I'm going to eliminate z. So what I'm going to do is I'm going to multiply the bottom one by -1. by -1. So what do I have here? I rewrite the first one. I got 4x minus 11z equal 10. The bottom one is -6x plus 11z equal -4. And then you add. Z gone. So that's what I meant by 3 by 3. You go down from 3 by 3 to 2 by 2. It's 4 and 5, 2 by 2, and now 1. So all you got left is x. So -2x equals 6. Solve for x equal, divide both sides by -2, x equal -3. What do I do with? Well, I need 2 more. I need y and z, right? So I just go backtrack. Don't go all the way back to the beginning yet. I would. There's nothing wrong with that. It just makes your problem longer. I would recommend you pick one of the equation 4 or 5 to plug back x back to solve for z first, right? And then when you have z and x, you go back all the way to the beginning, pick one of your favorite equation and solve for y. So I'm gonna pick doesn't matter, I guess number 4. I pick 4. So equation 4 is look like this. I got 4 times, I'm gonna make this into blue. -3 here for x minus 11z equal 10. So I got a -12 minus 11z equal 10. -11z equal to 22. Z equal -2. All right, equation 5. Oh, no, my bad. I'm sorry. Equation. I'm gonna pick number 2. The reason I'm picking number 2 because it just y is positive, y so it's easy for me to solve. Well, you can pick either 1 or 3. Okay. So equation 2. X is -3 plus y, which is plus y minus 4z minus 4z is -2, plug in there, equal 5. It's -2. I don't have space, so I'm just gonna go ahead and solve y for you. -3 positive 8 is positive 5. Oh, y equals 0. Y 0. So you got x, you got z, and you got y. And I would recommend you write it in triple order. Remember, we have double order, x, y, now x, y, z. So it's going to be what? -3, -2, and 0. Oh, I'm sorry, -3 for x, 0 for y, and then -2 for z. And that will be your final answer. Yeah, turn on my thing here. Yeah, -2. Oh, by 2. I'm sorry. Oh, by 2. No, by 2. Yeah, thank you, Taylor. I put -2 here, but then my head doing 2. I'm so sorry, everybody. Okay, so let me recap. So I give you 3 by 3. Now it's not always like this. Sometimes it's easier. Sometimes you get lucky and for some reason, as this step right here, you kind of eliminate z and y at the same time, right? Sometimes you get lucky, and all you do is just solve for x, and then you plug y and z back. But I'm just saying that the general rule is that you go from 3 by 3 focus on pick a variable you want to eliminate. You have to do it 2 times because you need 2 equations with 2 variables, like 4 and 5. Focus on one variable, do not change your mind. Once you have 2 by 2, you know how to solve from there. Okay, that's easy. Why don't you guys try this one? The answer should be a little bit weird, but that's okay. Oh, by the way, how many solutions the first one has? The 3 plane, remember each equation, it represents a plane. It's not a line, a plane. So what does that mean? The 3 planes meet each other at one point, right? Right. So that one. See people here. Today is Thursday. Okay, so today I'm going to try to finish 4.4 for sure, and then start at 4.5 a little bit. We only have one more lecture left. For 4.7, we don't. 4.7 is not required to finish. I don't think so. So we can do it if we have time. If it not, we don't have to. I want to do it because you did that. I think you kind of did that in 661. If you guys have an answer, put in the chat, please. Did you see anything funny? See anything funny? Oh, okay, that's right. Yeah. You pick Y. Okay, okay. Yeah, you pick Y again. Yeah, I like to pick something that is opposite. You can pick either X, Y, or Z. But if it's opposite, it's just easier. I wouldn't pick Z because the number's weird. 1, 7, 3, they have no common factor. Corey and Josh, can you turn on your cam, please? Thank you, Corey. Josh, you there? I hope you guys keep up with the bonus thing. That's for your final exam bonus. Of course, I had to put in a formula. It's not, what you see is not real, okay? I gotta put in the formula and then it's gonna give me something smaller than that. Devin is here on Monday. Corey there, Kevin not there, Alex wasn't there, Curtis here. Josh? I wonder if Josh can hear me. Josh, were you here Monday?
What was that?
Was you in the class on Monday?
Yesterday?
Monday.
No.
Oh, okay, thank you. Keep your cam on though. Taking attendance now. Jacob's gone. Haya's here, Mike's here. Kobe was there, Taylor was there. Today is 4th. Devin is here. Corey's here. Kevin, you here? Alex? No. Curtis is here. Josh's here. Haya's here. Mike's here. Kobe's not. Kobe? Taylor's here. Okay, what you guys have? Don't be shy if your solution is not the same as before. You probably have no solution, right? Okay, so somebody, let's see, I'm gonna pick Y to eliminate Y. You can pick X, right? But you should have the same solution as I do. So what I'm going to do is I'm going to label these 1, 2, and 3. So the first step is I'm gonna going to take equation 1, add to equation 2. I don't have to rewrite it. It's pretty straightforward. So 4x minus 2x is 2x. And then y is gone. Positive z, negative 7z, so minus 6z equal 1. Do you guys okay with me doing that? Yeah. All right, this is equation 4. It's new now. It's only 2 variables. Now you're gonna focus on one variable at a time. Okay, so keep eliminating y, picking another 2 equation. I'm gonna pick 2 and 3. All right, 2 and 3. So what I'm going to do is, I'm sorry, 2 and 3. So I need 6, negative 6, right? So what I'm going to do is I'm going to multiply the second equation by 2. And then the second equation by 3, right? So like I said, 2 times equation 2. Oh, let's say I'm just gonna put 2, it's just like that. 2 times equation 2, add to 3 times equation 3. This one I have to rewrite. So I got negative 4x, 2 times 3, 6 plus 6y minus 14z equal 2. I got, in the bottom, I got 6x minus 6y plus 9z equal 18. And then you add, gone. Negative 4x, positive 6x is positive 2x minus 5z equal 20. I'm gonna call this equation 5. We're gonna put 4 and 5 together. You don't have to write out, I'm just writing it for the note. Let's say I have 2x minus 6z equal 1, and then 2x minus 5z equal 20. Okay, something wrong here? I don't know. Did I do something wrong, guys? 2x minus 6z equal 1, and then 2 is 2. I meant to show you 3 cases: one solution, no solution, and infinitely many solution. But it looks like we have a solution. Let me go back to my notes, see what happened. This is 4.4. All right, 4x minus 3y plus z, 0, negative 2x plus 3y plus 0 equal 1, 2x minus 2y plus 3. Okay, this is the same equation. Damn it, 2, 3. Okay, something wrong, something wrong. Maybe we you know what, just go ahead and do it. Just go ahead and do it. Maybe it's not 2x and then negative 5z. Okay, that's fine. No, just go ahead and do it. Maybe the next time will come out the way I want. Go ahead and do it. All right, so I want to solve the 2 equations. So I'm gonna decide to eliminate x. So I have to multiply the first or second equation by -1, right? Whichever equation you want to choose. So let's rewrite this: 2x minus 6z equal 1, and then negative 2x plus 5z equal negative 20. You add. So I got what? I got negative z equal negative 19. This implies z equal 19. That's all right. Okay, now you got z. What do you think I'm gonna do? I'm gonna plug back to what? I'm gonna plug back to number 4, right? Equation 4 to solve for x. So you can pick equation 5. Nothing wrong with it. It's just choose something that make your life easy. So 4 is 2x minus 6z, z is 19, is equal to 1. You can solve for that. Go ahead and solve for it. So that 2x minus, what is that equal? 6 times 19? Oh, 54, right? Yeah, 54 equal 1. Add 54, so 2x equal 55. X equal 55 divided by 2. Leave it like that, it's fine. Now, I want to, something wrong. It's not supposed to be, huh? Negative 6 times 19. 6 times 19 is 54 or something. 6 times 19. Yeah, 6 times, I put 6 times 9. 6 times 9. Okay, 114, thank you. Thank you, 114. 115. Just leave it. Okay, something wrong. Something wrong, guys. Something wrong. Did I do anywhere wrong? Give me a second, okay? I'm gonna double check one last time. Negative 4x 3y plus z. Go ahead. I'm gonna plug back into number 1 to solve for z. See if it. God, I really hate this. It's gonna solve for z, and then. Did I do something wrong? It's supposed to be no solution. 1 plus 2 is 2x negative 6z equal 1. What did you get, Curtis? You picked x. Did you pick x to eliminate?
I eliminated
in the beginning.
I got the same thing as you.
Okay.
2x minus 6z.
Okay, and then the second time you pick, I picked 2 and 3.
I eliminated c at first, but then I got like a big fraction.
Yeah.
So
then, I should have eliminated x. But yeah, x sounds better than even y. But let's keep going. Let's see everything I did wrong. 6, 2 times negative 7, negative 14. 2 times 1 is 2. And then 3 times 6, 18. 9, 6, 2. Negative 14 plus 9 is negative 5, right? And then 20. Every time, I have no idea where I got wrong. It's supposed to solve. And then negative. Because z is 19. All right, let me plug into Taylor, read for me for I'll tell you what to read for me. Yeah. What is the value for z? We solve for z. What is it? 19. Okay, so 19 store for z is gonna be, I'm gonna say x right there, and then what we got for z? I'm sorry, no. 19 is z, right? So 19 store. I'm gonna pick letter z right there. Okay. And then what do we got for x? And store x. And read me the first equation.
4x minus 3y plus z equals 0.
Okay. All right. 1 second. All right. Let's solve for y. See what happened. Let's solve for y. Number 1 is not ideal. I should have eliminated x's. Number 1. Oh yeah, number 1. I'm gonna pick number 1 to solve for y. So 4 times x, put x there, minus 3y plus z equals 0. Z is 19, x is 115 over 2. Right, 4 divided by 2 is 2 times 115. Let's see. $230 plus 19, 249 divided by 3. Okay, I got y is 83. Good. Okay, y. Don't write that down. Let's see. Y is 83. I'm gonna go back here. So 83 stole for y. All right, read me the first equation.
4x minus 3y plus z
3y plus z. It is equal to 0. Darn it, huh? I'm supposed to go. Read me the second one. Oh, hang on. Somebody. Detroit. Shit. Oh, sorry. The second one.
negative 2x
negative 2x
plus 3y
3y.
minus 7z.
Oh, is equal 1. Okay, last one. Last one. Oh my God. I'm not supposed to have equation solution. That when you check all three solutions and it's turn out like that, I mean, it is a solution. So I didn't do anything wrong. Well, how come I have no solution in my notes? Okay, all right, let's write this, let's finish this. Y equal, maybe I did something wrong. No, Y equal 83. Okay, so your solution is, I meant this to be no solution, but I guess there's solution. So where's X? Okay, so 115 over 2, Y is 83, and Z is 19. Sorry, I didn't have space. You know what? I'm going to do this. I'm going to check with decimal, see what happened, okay? One last time. No, I don't want to end reading. I hope they take in this form. So 4x minus 3y plus z equal 0. I guess they don't take it. No, they don't take in this form. It's supposed to be a plane. I guess they don't like it. Let's say z equal negative 4x plus 3y bit. No, they don't like it. That's more, you cannot check it in. No, they don't like it. Sorry, can't show it on decimal. All right, so it is a solution. We check with the calculator. It turned out if you put a solution for all three equations, it turned out equal to the right hand side. So it must be the equation. But I don't know how I got no solution here. All right, last one. This is supposed to be infinitely many solution. I hope I don't fail you this one. By the way, we're nothing wrong with this one. Okay, just maybe I typed down something wrong. I changed a sign or something. So it turned out to have a solution, but nothing wrong the way we did it. Okay, so number 3, let me do this one with you. I'm gonna pick Z to eliminate. You can pick X if you like. So label 1, 2, and 3. I'm gonna pick 1 and 3 first because it's easier one, right? So 1, add 3, see what happened. 1 plus 3, so 2x. 2y plus 3y is 5y. Z is gone. 1 plus 4 is 5. This is equation 4. And then you're going to focus on Z still. Equation 1 and equation 2. So I want to eliminate Z again. Multiply the first one by 4, right? This one I have to write down. So let's say 4 times equation 1 add to equation 3. 4x plus 8y minus 4z equal 4. And then x plus 3y. I'm sorry, add to equation 2. My bad. My bad. So 2x plus 7y plus 4z equal 11. C is gone. 6x plus 15y equals 15. Now you put 4 and 5 together. I got 2x plus 5y equal 5. And then 6x plus 15y equal 15. I'll choose, it doesn't matter what you choose. I'll choose x again to eliminate x. So I'm going to multiply the first one by -3. So far, so good. Okay. Yeah. Just the same procedure. See what happened here. So I got -6x minus 15y equal -15. Rewrite the second one, 6x plus 15y equal 15. And when you add, what happened? Like slaughterhouse here. Look, everything cancel. All right. So on the left, 0. So 0, 0. On the right, also 0. Is 0 equal 0? Is it true or false? True, right? 0 equals 0 is true. So this means when you have some kind of this situation, you know that you have infinitely many solutions. Right? So what do I do? What do I do? See what the easiest way to show you this. What about, okay, so what I'm going to do is I'm going to let, try to find a way to show you the easiest way. Where I got this from? Okay, so I'm gonna let I'm gonna pick equation 3. I'm gonna pick equation 3. I'm gonna let z equal t and y equal s. You don't have to, but it's called parameter. These are your parameter t and s, your parameter. Now, if you plug t and s into equation 3, what happened to x? X equal what? So let me put x is x plus 3 is, instead of y, is going to be 3s, all right? Plus z is t equal 4. solve for x means subtract everybody. So it's gonna be 4 minus 3x minus t. So far, so good. And that's your equation. And that's your solution. So solution is x is 4 minus 3x minus t, comma, the y is s, and z is t. So what does that mean? It infinitely many solutions. So that means whatever number you plug in for s and for t, you get this one. So x depends on y and z. Kind of weird, but you get used to it. Okay, so infinitely many solution is like that. Infinitely many solution, it doesn't mean you kind of randomly pick 3 and then it's automatically give you solution. Okay. What you have to do is you have to pick a number for what? For t and s. And you have a number for x. That's why infinitely many solution, because you can pick anything for s and t, right? All right, so that one is it. I thought we need the extra page, so I kind of put it there. But that's it. Oh. Yeah, it's infinitely many solution.
I mean, it was no solution.
Oh, no solution should look like this. Yeah, I meant this is, I don't know how this come out to have solution. So for example, hypothetically, you have on the left hand side is 5. So 5 is now equal to 0. So it's 4. And then you stop. You don't have to do anything. That's the easiest one. You just say no solution. Nothing else you can do. The hardest one is the one with infinitely many solutions. On the exam, either I'll give you one solution or no solution. Right? I'm not going to make you do infinitely many solutions. That's for college algebra. Or for this level, you're not required to know a whole lot. All right, we're done. We're done with 4.4. 4.4. Now, I'm gonna go to 4.5 right now because I wanna at least talk about this a little bit before we continue on Monday. Okay. All right, Matrix. Have you guys seen Matrix? Not the movie. You know, in the book. Matrix is array of numbers arranged in row and columns. So what does that mean? That means it looks like this. Now, depending on what professor they teach you, for me, when I talk about matrix, for at least this level, I use what's it called, bracket? Is it square bracket? Yeah, some professor they use big parenthesis. Right. But I'm gonna use a square bracket to square bracket. I think in the book they use parenthesis. I don't know why. Okay, so matrix is like this. So you have a big rectangle array. So array mean what? You have first column, second column, third column, right? So I'm saying, so here is first column, here's second column, all the way to, I'm gonna say nth column. I'm not gonna write nth column, so just gonna say n. And then you have what? You have first row, and you have second row, and then you have all the way to say mth row. Just gonna move it to the left, to the right a little bit. Nth row, right? Okay, all right. So component, what does it look like? If somebody stay in on first row, first column, it's gonna be A11. Always row first. You always say row first. If somebody on the second row, first column is gonna be what? A21, right? And then if you're on the third row, first column, A31, right? So always row first and then column. Can you tell me what somebody here? A what? Yeah, A12. A12. Somebody else tell me what do I have for that one? Yeah, A22. So you got the idea, right? A22 all the way to what? What about this one? A what? What row? First row, right? First row and then n column, one n, right? A one n. Just by order, right? And then by so this one will be this one right here be A. What row you are? M row, but on first column, M1, and then all the way to the last one right here. What's this one? The very last one. What row? What column? Yeah, MN, right? So somebody say matrix 3 by 2. Excuse me. Then you know that it's 3 row, 2 columns, right? So this is a matrix. Matrix. This is let me do this. Let me do this. M by N, right? Where M is your N number of row, and N is the numbers of column. Again, always rows first, column next, second. Now, if I don't want to, I don't, especially in linear algebra, they're going to use this term a lot, Aij. If somebody say Aij, what does that mean? I row J column, right? Ij is just a placeholder. We use this a lot, improve in math. So this means what? This means, let me write Ij in different color, I, and then J. So again, I is row location, and J is your column location. Example, let me give you an example. I got so spoiled with this iPad thing. If I do something wrong, I can erase it and move it around. On paper, I can make a mess. I cannot, because I got so used to not being worried about making a mess here. On paper, I very awkward. Like, oh man, I make a mess like every 3 seconds. My student hate it when I write paper because it's not neat. All right, example. Number 1, 4, 5, 3, 5, 2, 3, 6, 2, 4, 1. Oh, maybe I should have put the 5 and the 2 far away a little bit. They're not together. Okay, tell me what the dimension of this. Dimension. So how many rows, how many columns? 2 by 1, 2, 3, 4, 5, right? 2 by 5, right? 2 by 5. So here, another example here. So 2 by 3, 2 rows, 3 columns, or 3 by 4, 4 columns. Let me introduce you a square matrix. Very important in math. If you have something that is not symmetric like these two got 2 by 3, 3 by 4, usually you don't do much stuff, right? But square matrix very helpful. A lot of properties in matrices require you have to be a square matrix. Square matrix mean what? So let me give you an example. 3, 2, 9, 6, 7, 8, 1, 3, 2. How many rows? How many columns? Yeah, 3 by 3. It has to be matched. Rows, number of row equal number of columns. So square matrix is n by n, right? Always the same. So that means number of row is equal to number of column. Very, very helpful. So far, so good. Just introduction to matrix. All right, another type of matrix is called augmented matrix. This one we're gonna use it when you solve in system of equation. So let me introduce you what augmented matrix mean. When I say augmented matrix, you know what I mean. So where does augmented matrix come from? It's derived from a system of linear equations, plural. So for example, if I have system x minus 3y equal 1, x plus 2y equal 5, am I recording? Yes. Then if I want to change it into augmented matrix, it looks like this. So the equal sign, I'm going to replace with a dashed line. And on the constant, so this the constant column is going to be 1 and 5. So far, so good? That's the right-hand side, right? Just the dashed line divide the left-hand side and right-hand side. This is represent the equal sign. On the left-hand side, instead of write down x minus 3y, all I need is the coefficient of x and coefficient of y. So 1 and negative 3. Same thing for the second one, 1 and positive 2. And this is called augmented matrix. If I can write correctly, augmented matrix. That's all. What does that mean? It just, you write out the system equation without x and y. Okay, why don't you guys try the second one? And we call it a day. Let's really stay a little bit, so I need to wrap it up with the syllabus. Josh, are you outside? Which is kind of nice.
I'm on like a deck right now. I'm in
Oh,
Traverse
okay,
City.
that's nice. I wish I
Yeah,
can
it's
teach
nice.
on my deck. That's pretty nice. Well, I don't think I can because the neighbor dog keep barking. My student, Mimi, I cannot hear what he's saying. So I go down to my basement. Anybody want to read it for me? What you have? So
I put the dash line in.
yeah, 1, 2, 1, and then the first one. Oh, okay. By the way, let's do horizontal just to make a habit. So 1, yeah, and then 2, 1, negative 1. Okay. All right. Let me show you something else, and then we'll call it a day. Actually, no, we're done. I'll show you next time using calculator. Right. I'm running out of time. All right. Give me a second. Let me go back to the course syllabus. Sorry, it's messy. Okay, so we on 4.5 right now. Next time we're gonna finish 4.5 and a little bit of 4.6. 4.7. Yeah, okay, so next time we're gonna finish D2. That's our goal, okay? Next Monday. On Wednesday, we're gonna go maybe, I'm gonna spend half an hour talking about 4.7. It is not required, but because you did on 661, I wanna do it again. So, so on Wednesday, August 10, we use different color. Talk about this one right here. Right. So first half is 4.7, and then another half we're gonna do a Kahoot plus grades. Maybe grade first and then Kahoot. Okay. Now I'm gonna hold a office hours because you guys have an exam on Friday. Let me tell you my office hours. I always have office hour after the class, and I always stay like at least 40 minutes after the class when you're gone, except for the exam day. So office hours on Thursday. On Thursday to tomorrow is gonna be What time is good for you guys? I mean, I'm free all day. Not tomorrow. I'm saying Thursday on the final week.
So if you did the after class, it's probably fine, 'cause we're already here.
Huh?
If you did it after class, we're already here.
Oh, okay, okay. So, but you guys don't know what question to ask me.
Oh, yeah.
Friday is you have, okay. So on Thursday, how about this? On Thursday, I'm gonna do it at night from 8 to 9, okay? Night. So everybody, you guys are not going anywhere from 8 to 9, right? Okay, so Thursday, the day before your final, I'll have offers. I have office hours 8 to 9 p.m. 8 p.m. to 9 p.m.